you have already know how to design the beam, yeah, but in the separate topic. Yeah? So now we have to combine it all, yeah, in one topic, that is design of beams. Yeah? So the design of beam, okay. Sorry. Okay, we must, before we design, we must establish our fire resistance. Yeah, whether, for example, whether you want to R60, 60 minutes, R30, 1 hour, and so on. Yeah, you determine the design life, exposure class, and also the action. Yeah? This one here, you have already covered. Yeah, we have already covered in our last lecture. Therefore, we determine the second step is size of the beam. Yeah? Just now we have already know how to determine the size of the beam. Cover, we have covered also the action yesterday and today, and structural analysis. Yeah? This is structural analysis. For the simply spotted, it will be easier. And for the continuous beam, maybe you have already learned in theory of structures for the continuous beam. And then we proceed for the design for flexure. This is from the last topic. Yeah, design for AS dash, and then design for shear, checking for the deflection, checking for cracking, detailing, and stop. That is the flow chart for the design of the beam. Okay. Before that, before we start design, look at the table 2.1 here. Can be obtained in your book and also in Eurocode. In order to design, the design working life will be determined depend on its uses of the building. For example, if you design as a temporary structures, it's only 10 years in the design life. Okay, replaceable structural parts. You do the maintenance, something like that. Okay, that is 10 to 25 years. Agricultural and similar structures, it is 15 to 30 years. Building structures, this is the common building structures. It's only 50 years. The design is only 50 years. Monumental building, this is museum, bridges, and other civil engineering structures, dam, and so on. It is 100 years. So this is called design working life. So we have 5 design working life. So the normal building, the office, apartment, school, and so on, it must be designed for 50 years. Okay, we have the example here. A rectangular reinforced concrete beam, simply spotted on 2 masonry walls, 250 mm thick and 7.25 apart, clear distance. The beam has to carry distributed load, distributed permanent action of 20, excluding self-weight. So this is permanent action, but without self-weight of the beam, and variable action of 18. The material to be used are grade C30 and grade 500 reinforcement. The beam is inside the building, subjected to 1 hour fire resistance, and designed for 50 years design life. Okay, so for the building, automatically it is 50 years. If the question doesn't mention, you need to assume it as 50 years. So design the beam. Okay, so we have here fire resist, list down the important data. So you have 7.5 span. How to get 7.5? Because in this question, two masonry walls, 250 millimeter thick, and 7.25 millimeter apart. So you have two brick wall and the beam. The clear distance, this is the clear distance, yeah. The clear distance is from here to here. This is clear distance, 7.25 just now. The clear distance is 7.25. And the brickwork here is 250, yeah, 250. Therefore, for the span, it must be calculated from the center of the brickwork to the center of the next brickwork here. So it is 7 to 5. 7 to 5 plus 25. 250 here. So you got 7.5. So that's why it is 7.5. Characteristic actions, permanent GK. Okay, permanent GK. Permanent GK on the permanent GK on the beam is 20. Variable is 18. Design life is 100. Fire resistance is 120. Yeah, 120. Just now is 1 hour. Yeah, 1 hour is 60, right? Okay. This is 60. 60 hours. Yeah. Okay, 60 hours. Okay, and SC3, okay. So after you establish everything.
Itu 60 hours ke 60 minit?
60 minutes, sorry, 60 hours ni lama. 60 minutes, 60 minutes, 60 minutes, okay. Okay. Once we establish that, barulah kita boleh, so we can design, yeah. Okay. Now, the first step after you establish everything, yeah. Now we need to find what is the dimension of the beam, yeah. Because the dimension of the beam is not given here, so now we have to determine ourselves, yeah. Okay. By using the solution given here is by using the control deflection, yeah, as I mentioned just now. H is equal L over 13, yeah. H is equal, okay. H is equal L over 13. So if you don't want this, you can change to 15, something like that. It is 13 to 18. So we have 577, yeah. B is 0.3 actually here, yeah, 1.4. So we have 256.50. Just now we have this. Okay. Now, durability, yeah. We have already obtained the size of the beam, H, yeah. So we need to find what is D. And during the design, we need the value of D. Therefore, in order to get D, you need to find what is the cover. So, as maybe you can remember, cover can be obtained from the three parameters. The first one is regarding to the bond. Here, the bond is, Simin from the bond is 25 millimeter because we we will arrange, we need to imagine that we will arrange in a separate ways, and the diameter of the steel is 25. So now you put Simin as 25. Minimum cover due to durability is 35. How to get 35? This you need to refer to the note last time, the note, the slide, how to get Simin, 35 millimeter. Okay. Okay. Let us look here. Okay. Look at table 4.3. Design working life of 50 years is S4. Here you can see here. Nampak tak ni? Default. When you start design, bear in mind that your design is S4 for the building. S4. Okay. Okay, now S4. Okay, to determine the structure class here. Okay, our design lab is 50, therefore we don't use this. We don't use this this parameter. Jadi tak pakai lah, because our design lab is 50. Strength classes. Okay, now we choose our X3. If exceed C35, then you reduce 1. So we use 30, so no reduction due to strength classes. Also ignore this. Member slab with geometry, no, we design beam. And then quality control, we don't set the quality control, we don't bother about the quality control, therefore ignore this as well. So now back to square one, our class is S4. Therefore we go to table 4.4. Let's erase first. Now our is here S4 and X3. So it is 25. 25. The value is 25. Okay. Now back to the our here. Okay, can you see? Okay, here just now we got berapa tadi? 25, right? So here 25. Okay, so ni salah lah 25 the value So 25 is for the durability. Boleh nampak tak? Can you see this one?
Boleh tak?
Yes.
Okay, minimum existent R60. So this one you can see also from the table. Table ni 4.4N. Okay. So the value of R resistance 60. our B is 250. Share screen. Okay, share. Okay. Where is the fire resistant? Fire resistant. So our R is 60, right? And our B is 200 to 300. Therefore, I would choose 30 here. I would choose 30. It's okay because 200 will give the higher value of A. Therefore, I choose 30. However, this is the formula. We got 24. So from these three, 25 millimeter due to bond and due to durability 25 and due to fire is 24. From these three, we choose the highest one, that is 25. Therefore, here is 25. So here is 25. Actually, this is 25. This is 25. 25. Okay. Okay, so this is 25. So you got value here is 35. 35. So the value here is 25. $35. So the cover now is 35. Okay. Right, we go to the next one. After you got the C, then calculate what is the loading that will be sustained by the our beam. So we have self-weight of the beam. Just now the question said that the permanent load from the self-weight is not included. So we need to calculate ourselves here. 0.25 times 0.65. 25 is the density of concrete. You need to remember this. So you got 4.06. Permanent load given 20, and you need to totally up, so 24. Then characteristic QK given 18. Therefore, we need to erase this. Therefore, now you can calculate what is the design action with this formula. 1.35 GK. This is GK. This is GK. And QK. So you got 59.48. Then you can do the analysis. Last time I gave you this one and do the analysis, and now you know how to get the design action. This is how we get the design action. Okay. Okay, the next step is to find D. D is very important. Okay, now you already have H, nominal cover, the link you need to assume. If the question do not give the diameter of link and the diameter of bar, you need to assume. Okay, so we have 565 and D dash C norm plus diameter link plus diameter of compression bar divided by 2, so you got 66. Okay, so you can calculate by yourself here. C just now is 35, 8, and this one is 25. So maybe you got different answer from this, because we changed the cover just now. Okay, let's see here, what is H just now? 650, right? 650 minus, sinom is 35 minus diameter link is 8 minus 25. So why do I minus only 25? Yeah. Okay, because you see the figure here. In my mind, before I design, I will arrange my steel into layer like this, so that the D is from the top of the beam to the center of the beam. Therefore, I will minus cover, I will minus the link 8, and I will minus with the 1 diameter. Yeah. But if you don't like, you can do like divided by 2. You want to arrange in one layer, so that you need to divide it by 2 here. So it's up to you. Yeah. So D dash, again, D dash is equal with 35 from the sinom plus 8 and plus, what is the diameter for the compression just now? 16. Is it 16? Is it 16? Hello class, is it 16? Okay. Senyap aja. 12, yeah? This is 12, not 16, eh? Sorry. This is 12. This is 12, eh? 12. Okay, 12 divided by 2. So you can get the value. Let's say 66, and you get the moment just now. Yeah, so this is the step design. You already know how to design. Yeah, so I will, okay, I will skip the step. Yeah, are you okay? Hello, are you okay? Okay, tak?
Okay.
Yes.
Okay. Step is easy. Yeah. Yeah. Last time you have AS dash and then AS, and this value, this AS, yeah, this AS must be checked whether it is in between AS min and AS max. This is the formula, the AS min, as we discussed yesterday. Yeah, this is for the control cracking. Yeah, this is okay. Your AS here is 2067 and is greater than AS min and less than AS max. Therefore, you can choose 5H25, which produce 2455 greater than AS min. Yeah. Okay. Next one is the shear. Yeah, shear design. Right. We have. Okay, you have done it. Deflection. Yeah. Yesterday's. We cracking. Look, the cracking. It needs GK and QK, and the delta must be equal with 1, because so far we don't consider the redistribution. Yeah. Simply spotted, we don't need redistribution so far, so that this is equal to 1. So now we have and lastly you need to draw it, the detailing. The detailing must shows the link and also the flexural steel here, compression, tension steel, and also the cross section. Yeah, the cross section that shows the link and also the tension and compression. Okay. Okay, any question? soalan?
Tak ada.
Tak ada? Oh, good.
Ada.
Okay. 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 Lastly, project. What is it? Okay. Okay. Can you see? Can you see the project?
Yes.
Okay.
Doctor.
Okay. This is the project, yeah. The project, as I have given this project in your e-learning, yeah. Okay. Okay. You have 2 tasks, 3 tasks actually. The first task is produce layout plan of beam and slab. Yeah. So this is must be carried out in a group. Yeah. So you need to create a group, minimum 2 to maximum 5 people, and then you elect a group leader. Faham ya sini group leader, and then calculate what is this parameter BD, date of birth of the group leader. Let's say the group leader birth of date is 12 October 99. So you just add it up, 12 plus 10 plus 99, so you got 1 to 1. And the BD here will be multiplied by this coefficient 0.008. So every group, the group leader birth BD must be multiplied by this coefficient times the L. L is the measurement in the plan given to you. Yeah. For example, okay, this is the plan that I give to you. Okay, I will go later. Okay, then all the measurement in the drawing must be changed to the new size. New size according to your group leader's BD. Yeah, so you will get the new dimension from the original one. Yeah, and then you need to draw the layout plan. After you got the layout plan, then the layout plan must be discussed in a group. You must divide the work between the group, because the work in the group is 5 marks. Okay, after you establish the layout plan, then you need to do the individual work, whereby each person in the group will design the beams and slab. One simply spotted beam and at least one simply spotted beam and at least one continuous beam, one one-way slab and one two-way slab. Yeah? And then after you design it, sketch the reinforcement detail of the beam and slab. And the third task is you must, after you design all of the elements, each individual must, you must collect all the individual design from each group. The leader must collect all the design report from each group and put it in a project report, whereby the task 2 will give you 10 marks here. Okay, so altogether it's 15 marks. 5 marks from the layout plan, from the group work, and 10 marks from the individual work. Then after finish the report, you can upload it in e-learning. The group leader must take this task, the step 3. Okay, any question? Ada soalan?
Doktor, task 2 tu kan tadi doktor sebut simply supported continuous two way one way kan. So seorang design salah satu daripada tu ke, ataupun setiap seorang kena design keempat-empat tu?
Seorang mesti buat 4-4 tadi. Each member of the group must design beam and slab.
Beam and slab untuk yang two way one way semua kan.
Yes.
Kemudian yang different maksudnya dia punya dimension lah. Setiap orang akan dimension berbeza.
Different beam, different slab. Nanti saya tunjuk dia punya ni
Layout. Oh, okay.
Okay. Let's see architectural plan here. View clockwise. Okay. Okay. Boleh nampak tak? Saya tunjuk layout plan ni. Tak nampak
Nampak tak?
Boleh.
Nampak? Okay. Okay. Nampak okey lah. Okay. Nampak Nampak ya?
Nampak.
Okay, this is the layout plan that every group will work on it. Okay. Okay. So this is first floor plan of a building, of the school building. If you can see here, there's a. Okay, sorry, make it larger. Okay, there's a hall. Day one means hall. This is the hall. This is a class. The class 1, class 2, 3, 4, 5, and 6. So we have first floor plan of a school. It consists of 6 class and 1 hall. This is hall, mini hall. Okay, so for the hall, as you can see from the layout plan, here, this is the class. The class will have a wall all around here. At all edges, we have a wall here. This is wall. This is wall. This is also wall. Okay. Okay, this is wall. This is also wall. So the class will have wall. We assume it has a wall. Okay. And for the hall, for the hall is a big empty room. It got here D1 is the door 1. So it has 3 doors here, and it has the windows. Okay. This is glass door. All right. So all you need to do is that determine where is the beam. The position of beam in this floor plan. Okay. Basically, when there is a wall, there is a beam underneath. Therefore, here you will have a beam. You will have a beam. Okay. Therefore, here we have a beam. Here also we have a beam. Here we have a beam. Here got beam as well. So here also beam. So the red line is actually a beam, yeah. Okay, and also for this side, for this, you need to determine the beam. Now, this is the toilet, restroom. Okay, this is also the beam. This is the beam. This is the beam. So every class will be separated by a wall. So there's a beam there. Underneath the wall, there's a beam, brick wall. Yeah. Okay. Here also the beam. Okay. All right. This is also beam. This is the beam. This is the stairs. Okay. Okay. This is also beam. Beam. This is also beam. This beam. Okay. All right. Now this for the hall, yeah. You can put beam here. It's up to you, but I will put beam here. It depends. It's better we put beam here because the span is 4.2 here. Yeah. But this beam will not support wall, yeah, because this is hall. You must remember that when you calculate the load, this one doesn't have a wall on it. Yeah, these two, but here yes. Yeah. Okay, and then this one, yeah. Okay, I will let this beam stop here. Yeah. So this is the pathway, yeah, the slab. So this will be one-way slab, long one-way slab. Yeah. Okay. After you determine the beam, the next step is to determine where is the column. Yeah. Okay. Usually at the corner we have a column here. Here also we have a column. Okay, column. It's up to you. Yeah. Maybe here column. Okay, here column. Okay. Here we have a column. Column. Here also we have a column, and so on. Yeah. Let's say every junction we have a column. Okay, the size of the column. Okay, you can assume as 250 by 250. The brick wall is 250, right? If you can see the size column of your house. Huh? If you have a concrete, your house is a concrete, so you can see the size, huh? Because this is 2-story, the simple building. Okay, so now this is the column. Yeah. So for example, from this figure, yeah, we can say that this is simply supported beam, supported by these 2 columns. So the member of the group, each member of the group can design one of these simply supported beam. This is also simply supported beam because it's only supported by 2 columns. This is also simply supported beam. And this is continuous beam. You cannot design just one part, but you must consider from here to here. So this is continuous beam. Yeah. All right. So this is maybe 2-way slab. This is 1-way slab. So each member of the group must design different beam. Yeah, we have a lot of beam here. Yeah? Okay, and the dimension here is depend on your birthday of your group leader. Okay. Okay. Any question?
Ada.
Okay. Tak ada
Tak ada, Doktor.
Okay. Kalau tak ada, saya nak tunjuk lagi ya, saya nak tunjuk.
Doktor, sorry guys, sorry. Yang untuk slide design beam tu tak ada kat e-learning.
Belum, saya belum masukkan.
Okay. Siap dah.
Doktor, projek ni hantar bila?
Projek ni ya, nanti saya bagi tahu. Saya nak kena tengok apa ya, timetable tu. Tengok dia punya bila hujung bulan Mei lah. Hujung bulan Mei kan habis lecture. Nampak tak apa saya upload ni? Ada nampak apa saya upload?
Upload apa tu?
Saya nak tunjuk contoh belum Tak nampak
Ada Doktor tengah padam.
Saya tengah padam dululah. Ada kelas Cek. Nak ambil dah. Okay, apa tadi saya nak share screen. Ni nampak Okay, this is the example of layout of beam slab that you need to do. Yeah. Nampak Hello, nampak?
Nampak.
Macam ni
Nampak, Doktor.
you must show the grid, yeah, the beam size and so on. You need to determine how you determine this is based on the method that I taught you just now. Okay. Okay. So sekarang dah 10. Time's up. Okay, ada soalan? Hari ni tak ada, ambil lah.
Doktor.
Ya.
Yang drawing arkitek ni kita cari ke atau doktor bagi?
Saya bagi. Guna tadilah.
Oh, okey.
Ada di dalam tu e-learning. Ada di dalam e-learning. Kalau tak clear, saya nak WhatsApp you lah nanti.
Doctor, for the file determination of cover for the part of Euro code,
Yeah.
that file is not in the e-learning. The one Doctor uploaded is the transverse shear one.
Oh, really?
Yeah. For me, I don't know whether it's the same for the class.
Doktor.
Doktor.
Okay, I will check. I will check that one. Okay.
Thank you, Doctor.
Okay. Bye-bye. See you. So next week, let's do the layout first. Yeah, you can show me next week. Okay.
Okay, Doktor.
Okay, Doctor.
Thank you.
Thank you.